Turn the page to example 2. I'm going to show you how to find the value of a slope.
It's not that bad.
Alright, so we're going to look at the value of a slope. This is a number basically to communicate how intense a slope is. Okay, that's what the value of a slope is. It tells you how steep or how intense that slope is. Okay, there are several ways to calculate the slope of a line. All of these ideas, all of these ways, are based on this fundamental idea that slope is equal to rise over run, which is something that sounds already very familiar to all of you. Okay, that's good. What does rise over run mean?
So isn't it like X and Y
Rise
or
is
something?
Y and run is X.
Yeah, if I have a line, the rise is how much vertical I gained in relation to the run, which is how much horizontal I gained or lost. Okay, it's a ratio between these two values. How much did I go up compared to how much did I go across? Okay, and the higher you make the rise, the steeper the line. The longer you make the run, the flatter the line. The shorter you make the run, the steeper the line. Get the idea? I just draw lines all over my notes now. Okay? Rise and run. For some very strange reason, mathematicians, or a mathematician, chose the value m, or the letter m, to represent slope. So whenever you see m from now on, it will usually mean the slope of a line. And I did some research as to why that is, because I've been studying math for a while now, and I didn't know, and I would like to know. And I can tell you with a somewhat high degree of confidence that nobody knows.
Nobody knows a lot of things in math.
No, that's not necessarily true. I find it strange that nobody knows because math is usually a very precise science, right? A very, very exact science. So you think if we had m for slope, somebody would know why. I used to think they used m instead of s because s kind of looks like 5 and it can be confusing. But no, they used m. Some theories say that it used to stand for modulus. Don't know how. Other people say that René Descartes, the guy who made this thing, the Cartesian plane, he used it in his notes, and so people thought, oh, Descartes is using it, so why not? Euclid also used it, and so people are like, oh, Euclid, he's smart, let's use it for slope. But nobody knows.
What if it's slope in a different language?
No one knows. Why is it m? M and slope have nothing to do with each other. M is bumpy and slope is straighty. Okay? Yeah, no one knows. But who cares? Okay? That's what they do. That's one of the weird things about math. But anyways, go to page 320 in your book. We're going to look at an example, a quick example of finding the slope of a line. Okay, page 320. We've got a picture of some trusses. You guys know what trusses are? Okay, a truss is the thing that you put in your roof to make it pointy so that it doesn't fall down. Okay? So here's a truss. The height of that truss is how much?
10 feet.
The height is 10 feet. What's another way of saying height?
H.
Okay. Rise. That's what I was looking for. So in our formula, m equals rise over run, or slope equals rise over run. The rise would be 10, right? Now how about the run?
48 feet. Is that what it is?
So the span of the truss goes all the way across. That is 48 feet. But what is the run? Is it 48?
No,
Yeah.
it is 24.
Why is it 24?
Because, yeah, you got your thing.
What am I trying to find the slope of?
Your top point, right?
Trying to find the slope of the roof. This right here, right?
Just one side.
So I only care about the run from here to here. The height from here to here is still 10. But the run from here to here is halfway. So that would be 24. Okay, so the slope would be 10 over 24. Reduce that fraction to, what do we do? Divide by 2, so that's 5 over 12. As a decimal, that's what? 0.4, give me 2 decimal places. 4.42? Okay. 0.42. Right? So this gives you an idea of the slope of that roof. Is it a steep roof?
No.
No, it doesn't look like it. Maybe in reality it'd be a little steeper, but that looks like a pretty standard size of a roof. Good. You get the idea? Rise over run. That's the most fundamental way to calculate the slope of a line. Okay, how much did you gain vertically compared to how much did you gain horizontally?